Two motives. Hello, mentors. Laura, a street artist from Santa Ana, drew two motives. Each was a scaled copy of the other, so one was bigger than the other. The one that's bigger was, say, 100%. The other was 60%. So we have this relative relation, right, between them. One of the motives had 60% of the area of the other. Together, we also know both motives covered 3/4 or 75% of the whole canvas. How much of the canvas covered each motive? So we are asked, in terms of the whole canvas, what's the relative size of each of the two motives? And so this is one of the challenges of meeting 3, street art, in which students will have to reason more abstractly than before. So let's take a look at how we could solve this problem. We could say that we have this first motive, and we just draw 3 squares. And this is a way to relatively know that the other would have to be 5 squares. So this is a 3:5 ratio, or 10, 6 to 4, sorry. So 6 to 10, sorry, if we double this. So let me just quickly explain how we got to this. Remember, one of the motives was 60% of the others in terms of area. So students could draw also this, 6 to 10, but it's much simpler to draw 3 to 5. Let's put them together like in a line, forming a line, and then let's just, stretch them a little bit so that we can still have the relation between these two motives. And now, what are these grids lines? Well, this part that says that both motives together cover 3/4 of the canvas. So now we can see that the whole canvas would be this big. We can see that the two motives are 3/4, exactly 3/4 in size. And then we can see that they have a relation 3 to 5 or 60%. Now, I'm not claiming that the motives are this shape or they have this rectangular shape, because these are actually not scale copies, right, of each other. But rather, it's just a visual way to reason in generality, to reason abstractly in a visual way. So these are called bar models or bar diagrams or tape diagrams. But it's just a visual way to represent information. What do we do now? Well, we just count. So we have these parts or bricks, and the whole thing is made of 32. And then for the motives, the first one will have 9 parts, and that's 9 over 32. So that's the relative area of the first motive. And the second, same idea, 15 parts, just count. So 15 over 32. Of course, 15 plus 9 would be 24, and 24 over 32, it's actually 3/4. So we are good with the problem. But then, how far can we go? So this problem ends here, technically, that's the solution. But what would be an actual example of two shapes, two motives that are scale copies of one of each other? Because this is a solution in an abstract way, but the motives cannot have these shapes because these are not scale copies, right? The red one is just a distortion of the green one. So here's an idea. There's several ways you could try it also with other methods or with other types of canvas, and your students could also do it. You could start with a copy that's a little different version of this one. We just give room for the other scale version. It would have 15 parts, right? So that is 15 over 32 of the canvas. So that would be the large copy of the motive. You can see 3, 3, 3, 3, and 3 here. So that's 15. And then the other copy, remember, must be 60% of the size of the red one. So which one will do it, right? So maybe this one, but no, that's way too small. Maybe this one. Is this 60% of the size? How can we tell? So it's not that obvious at first glance, right? So what we do is the following, and your students could reason in a similar way. At the end, we want a 60% area. Since we have a scale version, both the X scale and the Y scale must be multiplied by the same scale factor. So in other words, if we reduce this by 50% vertically, we also must do this horizontally. So we must respect that. So that tells you that we need a number that when multiplied by itself, it's equal to 0.6. At this point, students may know about the square roots and work with that, make sense of that. If not, they can still do trial and error and say, for example, what's 0.8 times 0.8? And of course, that's not going to cut it, but it's close, right? Because 8 times 8 is 64. So that's promising. Maybe 6 times 6. Nope. That's way too small at the end. And so on. 7 times 7. Nope. Too small because that's 49. So it'll be just almost half as big. So by trial and error or by taking roots, students will discover that it's actually 0.77 and then some more decimals, but let's just take 77 because that's a good approximation. So what happens is that this copy, it's actually 77% of the height. You can see it here, right? 77% of the height, and also 77% of the length, right, from left to right. And it's a scale copy. Let's see why. Let's see how can we tell scale copy, right? Same proportions. So it works. And then I can put it anywhere in the canvas as long as it doesn't overlap, right? So I can put it here or here, many different options. So this would be a more, satisfying solution to the problem if you want to take it one level further. So hope you enjoyed this video and see you in the next one. Thank you.